Hey guys, it's Nansen here of Alan Northpole. Today we're doing a video about two books. The first one is about social physics, how social networks can make us smarter. And the other book is about the power of experiments. And I'm doing this as part of my series on Catalyst. So without wasting your time anymore, let's get into it. It will be just a short summary. I can't show the whole book, obviously. That will be an infringement on copyrights, but I can discuss some parts of the book for you. So let's do that. So what I'll do is highlight a few important things, and let's get into it. First, page 9. Let's see. So what I want to highlight here is that there's a big revolution now in how we look at social data. This comes back from how we do social sciences. Usually before we had this maybe long observation of a single factor when it came to social influences, mainly because it was very hard to track a lot of data at the same time. So this goes hand in hand with the IT revolution. For example, the mobile phone makes it a lot easier to track social interactions. You can have devices on you that can track how close you are to others. It's just very much easier now to make data that's really quantifiable, like for example how close are you to a person, how often, how do you move from person to person in a group, really physically measuring social factors. This is the basis for the social physics studies. And the big premise there is actually that you want to have groups that are efficient, that have social intelligence, and as you'll see, there's some good findings on how to create these good groups that creates what they call good ID flows. So let's look at page 29. Let's see, this is the wrong page. Here. Okay, so one powerful demonstration of just how good it is to not have on one end of the metrics like just isolated people thinking about something, and on the other side of this metric an echo chamber where you have a group repeating the same IDs over and over. What you see here on the right is really data from eToro and actually return on investments based on this group. So isolated investor actually made worse return on investments. Luckily most of them are in plus, some are not. But the same can be said like an echo chamber. Sure, there was some ideas and it generated some profit, but the most profitable group, the highest profitable group, are the ones who are in between, that are not in an isolated trader situation. They are not in an echo chamber. They are getting the most diverse IDs, not the same IDs over and over, and not your own IDs only, not enough IDs. So this is a very powerful example of how these social physics actually matter and give real results. So with that said, let's look at the next page. What you need to have is, or what they find in this social physics, is that the social learning part of it is critical. That you can copy other people combined with individual learning. That's dramatically better than individual learning alone. This is makes sense just from an intuitive standpoint. But really the way we do it in everyday life, we don't emphasize this enough. And diversity is something that's important because as with nature, you want to have diversity so you are more robust to handle both opportunities, new scenarios, and also the opposite, big dangers and threats. This is why, for example, ants have diversity. Not all of them are out working. Half of them are still in the nest. And basically, this is to prepare in case and have this diversity. This is something that's hugely important in nature. Just think about genes and how well we are different, and that creates a better survival rate. And contrarians are important. So you need also this type of independence in having other types of ideas. So ideally, you will not have this one group that have the same types of ideas. What you want is a scenario where you have different groups that all can come together and create the best ideas together. Let's see. And to create these idea flows, they actually have done some measurements, and as I said earlier, they're physically measuring where people move to each other in a group discussion. What you want to have is like interactions where you interact with every member of the group. If there's just like one member always interacting with the other but not to the third, this pattern of interaction actually has been proven in some studies to improve the group results just by making sure to interact with everyone in the group. And they actually found that it's better to have these short engaged talks to each other than to have a long discussion with one single member of a group. And this is really part of social physics, and it's very interesting that they can actually find results on this. And it's a new way of thinking. Let's see. Just hopefully I'm on the right page. So to do this, you need to have this social intelligence, and actually, this can be trained, but some people have this on their personality traits, that they are not very outgoing or charming in that way, but that they actually enjoy listening to a diverse set of ideas, and they enjoy facilitating more ideas. And the goal is in this scenario is to measure some form of ID flow. How fast are the IDs flowing? So again, it's a physical measure. You try to do something that's abstract, namely the ID, and you try to measure it physically. For example, how many interactions are there in the group? And the goal state is to have a high degree of ID flow. So it's another way of thinking about social metrics, really. And finally, I want to show. Let's see. Just hopefully on the right page. Let's see. This is not the right page. Let's try again. '66 maybe. Let's try. Yeah. So here again they have this rate of ID flow. But you have to be a bit careful about that, just to show I'm not blindly swallowing these ideas of social physics. What they are trying to show with this picture is basically that a city that is designed to have more good public transport, and they think it would relate to higher degree of ID flow because more people will move between different places quicker, and you will not have isolated cities within cities because of the very bad traffic situation. And they suggest that the higher you have this measurement of city design that causes better ID flow, the higher the GDPR of the per square mile in that place. But you could also argue this could be the third variable problem. What are you actually measuring? Because rich cities have and can afford better public transport. So you could be really just measuring that the cities are rich, that's why they have good public transport, and not that the public transport itself caused them to be rich. That's called a directional problem. And it's a third variable problem as well, because it could be a third variable causing this, because in this case I think it's the rate of ID flow that's the variable causing it, but in reality it is some other reason why this city has a high degree of GDPR per square meter. So I'm not necessarily buying into that, but I definitely buy into the fact that the higher degree of ID sharing in an efficient way you have, the more chance you have of creating the best ID. It just makes a lot of sense. And then what social physics brings to the table is, instead of this old type of measurements where we maybe try to infer something inside the human mind, we actually try to quantify it physically. And in this way we can better do our data, because it's very hard to infer something that's like, what's an ID? That's an abstract concept. But how often you move between people in a group, that's very quantifiable. Yeah, so that is my part about the social physics, and we will move on now to the part about the power of experiments. And I don't want to bore you with the whole book, but the one thing I want to talk about is like the theme of experimentation, and how we see it's more powerful now because we have more access to data. We have been for some time, of course, very interested in experiments and the scientific revolution since the time of the philosophers, where we started to wonder about the mind and do these thought experiments, and then finally later we try to make quantifiable data. And where we are now is that not only are the scientists doing data, the different corporations like Google, eBay, Uber, they're all trying to quantify data. And one of the main points in this book is that there's no shortage of data at this point in society time. It's so easy to track data now with the Web3 and all of the data that's generated to these corporations. But the hard part is actually asking the good questions, because and this is one of my key things about, for example, Catalyst. It's not the voting itself that's the problem. It's the creating the good process to get to something that's quality to vote on. And the same is with science. Like, it's quite easy in today's age to have all of these different types of tallying up of data and measuring the data. That's not hard. We have great tools for that now. What's hard is to make sure that you ask questions about the data correctly, and that you infer something about the data that's correct and true and that's useful. Let's just summarize the themes of the book. This is a great book to read. Like, it's fairly general, so you don't need to be have a scientific background to understand it. But basically we are still at the beginning of an experimental revolution, because we see it's now moving from the scientists, the universities, where maybe you have 100 people in a study, to know the big corporations measuring data and doing short time studies with maybe several 100,000 people at the same time. And much of this has been for greater good. There's like, for example, they just measured different wording of a tax letter for the British government, and they found that they could get a better tax return rate just by describing how many other people have actually paid their tax. So 9 out of 10 have paid their taxes, for example. And you could argue that's good for society, that it's more efficient than forcing to have paid tax. Also, there's and this is more questionable to me, like voting. They had this measurement that actually showing up or calling is way more efficient. Showing up or writing a letter is way more efficient than phoning someone to encourage them to vote. and this was used by the Democrats in the US, and later now it's been established for everyone, even the Republicans. And the point there is that it could be good for the group utilizing it. So just like any tools, these types of understanding of experimentation with social matters such as voting, you need to use it carefully, and in this case the best part would be that a neutral third party will actually be one to encourage. So you will not encourage voting only in this area of the city where Democrats are higher chance to vote versus this other side. Then you would have this better engagement in the voting process overall. Yeah, and that's the point of the team tree. So because experimentation makes organizations smarter, they can have negative effect as well. Because if you agree with the goals of the organization, then of course experiments are great. But if you are against the ideas of the organization, then they are actually making it do something you don't want it to do. Such as if you're a Republican and it's used for Democrats to vote more. And these experiments they have shown is valuable not only in the tech sector, because in the corporation now it's mostly the tech sector because it's so easy to have this data. But they see now that also non-profit organizations and policymakers can use this data. And for me, of course, it makes sense. Data is data, and it can be used in any type of scenario. It's how you measure that data, what type of questions you ask, and what results you actually are interested in. Then if you do that properly and have a good process for that, you will create value. And they argue that there's still a lot of ways to go with experiments, and that we don't use it in general. Like, for example, does people in general think experimentation is a good thing? Experiments can both test a theory or hypothesis, or even just develop or refine frameworks, and they can even help you evaluate an existing product or policy. And most importantly, you can use it for fact-finding when no theory yet exists. So generally, the book argues that you need to have this type of willingness to do experiments. Even if the status quo is safe, you should always try to improve and accept this uncertainty by having periods of experimentation. Because it could be designed relatively low cost, and they have such a great potential for good. And for me, when you compare with, for example, catalyst groups, we should allow ourselves to fail and allow ourselves to dare to experiment a bit with different types of social physics and ways of idea flows, and ways we create these groups and interact with each other, so that we can find a system that creates a good process for us and makes us efficient at what we're trying to do. And for example, if that we're trying to do is being a direct representative, that means we need to find processes that creates high quality understanding of a matter subject and a high quality of implementation, voting on product that actually succeeds. And for that we need to experiment with these social processes, because among us in the Cardano community there's definitely people who have the domain expertise and other expertise that together can create and make value on voting on a project. And that's what we're trying to aim for. So encouragement is don't be afraid to fail. It's okay, we have had catalyst circles, we had different types of voting methods. That's great. We are improving slowly and surely by creating understanding of how we work as a group on these things. So that was my 2 cents about these 2 books, and I hope you enjoy it. Bye for now.